So I'm probably not the only person that has a compressor in the basement because you either don't have space in the garage or you don't want the noise. I know some people keep theirs outside. And so I have this compressor, nothing too fancy, one cylinder. You can see there's a bit of a fancier drain on it with a manual valve and an electric valve. It's suspended above the ground to make it easy. And then it's plumbed in there using one of those systems that goes everywhere. And so the thing with this tank that gets me in trouble the most often is that I'll turn it on and it will choose to refire at the most inopportune times. So this video is showing you a device I came up with that really solves that problem from my standpoint. And I'll show you more now. So here's a look at the typical system. Most houses or shops have an air compressor with the pump on the top and the tank in some form, and then a drain at the bottom. This works really well most of the time if you're in the shop, or if you leave it on, or if it's located somewhere where the noise isn't really an issue. But for me, noise was an issue, and so I came up with this, and please excuse my lack of professional drawings. What I have here, same compressor with the drain and the power coming into it. And so we'll start from here. What I have here is this ESP8266 chip. It's the cheapest Wi-Fi chip you can get, and essentially it's a fancy Arduino that's got a built-in Wi-Fi. And what I've got running off it is I've got a temperature and humidity sensor. It will tell me the temperature, the humidity of the ambient air nearby. And that is powered by a transformer. Basic 12 volt transformer that then gets bucked down to 8266 5 volts. And that's plugged into the power. The other side of the power runs to two relays, and these relays are controlled by the ESP, simple 10 amp relays. And one is used for the drain, so I have an electric 110 volt drain. And then the other is the 110 volts coil side of the contactor. What a contactor is really nothing more than a fancy relay. I have a 35 amp relay, came from Amazon. I think it was about $11. Far from anything expensive. The interesting thing was I had to put the contactor away from the relays because when it would slam open or closed, it would knock out the Wi-Fi signal. So really, if you think about this, we have 220 volts going into the one side of the contactor. It then closes both legs are switched, and that then turns the compressor on. Or at the same time, from the chip, I can fire the drain either permanently on. My drain has a timer on it, so you can either run 5 seconds or 45 seconds. Sorry, from 5 seconds to 45 seconds, and you can run it between every minute and every 45 minutes. For a home shop, that's a little excessive. You'll never need that. So mine's really designed to come on once a day. It comes on for 40 minutes. So that ensures it fires once, but usually when you apply power, it will run immediately. And so looking at this, the one thing I would say, if I did this again, I would just buy a cheap nitrous solenoid and use that on the bottom here. What that would allow me to do is I could probably just use a 12 volt circuit instead of needing 110 volts. So that's a look at the schematics. I'll include some links to where I got the project work for the software. And so here's a quick look of the control panel. As you can see, uptime, we've been up for 4 minutes. I just plugged it back in. Humidity of 58%. Temperature of 73%. Pin 1 is the compressor, so if I turn this on, I will be hearing the compressor. And I'll turn that off because I'm sure my wife hears it. And then for the drain, I will usually just fire the momentary rather than the whole process. So pretty quickly, you can see all of that. In future, I intend to add the line item for the pressure. So I'll have a pressure update on that. Basically, this is set to reboot every 45 days. This code is all open source. And this is really just the web frame that's used. And so if you didn't have a smart home and you just wanted to control it via a website, you would just literally go to your IP address, find the device, and from there you would be able to turn things on and turn things off. So that's the high level view. So right now you can see both things are off. And that's the web view. So now I'll show you the other view. And so here's a look at the SmartThings home automation system. Not too advanced. Basically, I pick an area. My basement, I have a water heater sensor and then the air compressor controller. Then when I open this up, essentially I get the compressor, the drain valve on and off, the ability to reboot, clear the tiles, refresh, which will go pull a new status, then the temperature and humidity. The one cool thing with this is you're able to set conditions for the compressor to go on or off, as well as the drain. You can use something like if this, IFTT, if this then that type logic. I've got some logic set up that if the temperature goes too high it won't turn on the compressor, or if the hour eclipses 9 p.m. it won't turn on. The drain usually fires at around 10 a.m. every day regardless, and so if I come here, click refresh, hopefully it'll go pull new signals from the unit. Okay, so here you can see that it's on and off. The one nice thing is if I hit this, it'll tell you that it's actually trying, and what it's doing is it's searching to see if it can get the signal back that says the relay is open. It looks for that load. So now we're compressor on, and then I'll turn it off, and I can distinctly hear it through the corner. So that's really a look of this. You can see the activity when it was last on, when it was off. Some good auditing if you have any need for that. There's some other fancy things that I have, so I'm able to work out, let's see if this page didn't load, but essentially I'm able to load information such as what fires off when, and then I also get some power consumption reports as well. So that's a look at what I use the SmartThings portal for. I actually have, I don't have it defined as a room. Let's see if I'm able to add this. So I actually have a garage heater, so I should probably have a garage and then my two doors. So I'll actually build that really quickly. So now if I ever wanted to control the garage, I have a quick, easy access. And the garage heater, there's a video for that one as well. Essentially, if the temperature gets to a certain point, it will turn on, and if it gets too hot, it'll alert me. And it will only really do that in winter, so it needs to be below 40 degrees to turn on. So that's a quick look at the home shop automation, starting to try and get into more of these type of projects. And so here's a look of the actual components, not just a sketch. I have one plate that I have the ESP8266 chip at the top. It's fairly simple, it's actually minute in size. Then there's a middle board with the temperature humidity sensor, which is the blue piece on the left hand side. And then we have a 12 volt input next to it, as well as a couple other bridge pins that I'm going to use for the future pressure sensor. So there's quite a bit of upgradability. There's about 30 inputs that are possible. And then beneath that are two relays. The left one controls the compressor, and by compressor I mean via the contactor, and the right one that I'll show you here, the right one controls the drain. So not too terribly complicated. Then inside this box, as I said earlier, I use this to shield the, I guess, the pulse or whatever frequencies are coming out of the contactor. You can see there's 110 volt in on the very right leg, then there's an input and an output. And for the most part, this box is really just wire nuts and connections. And what that does is it goes up to the top, so the one relay controls the green point, which right now is an extension cord, and then that's the 12 volt converter is the black module. So now here at the bottom, here's a look at the drain. This was an eBay special, not too fancy, and you can see the timing that I was talking about on it. So this is one of the projects I've been meaning to do for a while. If you have any feedback, any ideas, anything you see that you'd like don't like, or if you have any ideas for future projects, please let me know. As always, I appreciate thumbs up. And if you aren't a subscriber and are interested in these, I'm looking forward to doing more in the future. So thanks, and have a great day.